Hello everyone. In this video we will see about the basic bipolar junction transistor operation, and then we will take a C common emitter configuration, and then we will perform their input characteristics and output characteristics. So basically a bipolar junction transistor means here we have two junctions and then which we have three terminals, that is called emitter, base and collector. So now to see the performance of C configuration, we will take emitter as a common terminal between the base and collector, and then we will apply the input towards the base emitter side, and then we will take the output in the collector and emitter side. So before going into the performance of a common emitter configuration, at first we require a basic BJT transistor. We will do it for an NPN transistor. So here go to select component symbol and then choose your NPN device. So I have taken NPN device, place it here, and then this is your base terminal and this is emitter terminal and this is a collector terminal. So the emitter terminal will be common, so let me put it as a ground point, and then here the base is the corresponding input side. So we should have some resistance in input side. So I have added some resistance here. And then this is the output side. In the output side we have a load resistance. So now here we will give the biasing on both the sides. So why do we give the biasing on both the sides? Because to act as an amplifier, the BJT should act as an amplifier. So when we give input side as a forward bias and then output side as a reverse bias, that means that between base and emitter we will make this as a forward bias, and then between your collector and emitter side we will make this as a reverse bias. So then only it will act as an amplifier. So now let me take an voltage component. So here you can see the base is the corresponding base has been given to the positive side, and then also here I have given the positive to the negative side. So the base is your P terminal here. The P is majority carriers are holes, so the holes plus, and here I have given plus, so both are forward biased. And then the output side collector is the N terminal and collector is the N, and then the N which have the majority carriers are electrons. So to make it as reverse bias I have given the positive towards the collector side. So I have made the input side as forward bias and then output side as a reverse bias, so to work as an amplifier. So let me give the input voltage as a 5 volts and then reverse bias voltage as a 5 volts, and then give some resistance as a 100k and output resistance as a load resistance 10k. So now we need to sweep this to find the input characteristics. So we will plot an IB versus VBU. So we should find the base current, and then to find the output we will find the collector current. So to do that we go to edit and edit simulation command, go for DC sweep, and then select your voltage source. So now we will sweep this voltage source V1. So type the name as it is V1, And type of sweep is we need to do linear, and start value is 0, and then the stop value is 5. That means maximum 5 it will go, and it will increase by 0.1, 0.1, 0.1 times. And then second source is V2 to go by linear. The start value is 0, and then end value is 400 millivolt. It will increase by around 40 millivolt. So now let us go for simulation. So now here in the right hand side in the graph, please right click and then add traces. So which are the current we need to see? We need to see the input current IBQ1. So you can see here, since it is a silicon transistor, until 0.7 volts it is not turned on. After 0.7 volts it's linearly increasing. The current is linearly increasing the input characteristics. And to see the output characteristics, we can see here add trace. Color is the output side. So IC of Q1. You can see here. So we have three regions. One is called active mode, and another one is called cutoff mode, and another one is called saturation region. So where here we have plotted and then corresponding collector current with reference to the collector emitter voltage for different bias current. So here whenever there is these are the constant voltages. You can see here the lines which are single line, straight line. These are the lines which are in active mode, and when the current is linearly increasing, these are called saturation mode, and then when both the sides are in opposition, this is called cutoff mode. So this is how we can see the BJT operation with the common emitter configuration. Thank you for watching.